Next we are going to discuss the ratings of the circuit breaker. So first, if you consider the rated voltage, this is nothing but the voltage that the circuit breaker must bear under normal conditions. Similarly, you have the rated current and rated frequency. Okay, so this pertain to the normal operating condition. That means there is no fault. That is no fault. Next we have the important ratings, the making current and the breaking current. So this pertain to the fault conditions. Under fault conditions, this is going to be the current waveform, the short circuit current waveform. Okay, so you can see that there is a transient part, right? It is decaying with respect to time, and there is also an oscillating part which is going to sustain, which is going to be sustained even after this transient part has decayed. Now we have already discussed the circuit breaker doesn't right away break away the contacts, right? It will wait some time. After that only it is going to break the contact. So now you can see at the very instant of the short circuit, the current is going to be very high. The instantaneous current is going to be very high and it is going to reduce over time. Okay, fault current itself is high, but at the instant of fault occurrence, it is going to be even high. Now the circuit breaker, it should be able to bear that instantaneously high current. Okay, it is very high current, but it is flowing only for a certain instant of time, for a very short time. So that the circuit breaker has to bear. So this I1 here, this corresponds to the making current. Now what is the breaking current? It is the current that flows at the instant the breaker contacts are going to separate. So here this is the instant of separation. Now the breaking value is taken as the RMS value. So it is going to be, there are two kinds of breaking current. One is the symmetric breaking current and the other is the asymmetric breaking current. Okay, so symmetric breaking current only includes this oscillating part. So X by root 2 will be the symmetric breaking current. What about asymmetric breaking current? It is going to be the effective RMS of this X and Y. So you can note this down. Symmetric breaking current, from the diagram, it is going to be the RMS value X by root 2. And the asymmetric breaking current, this is going to be the effective RMS. So what will that be? Root over X by root 2 whole square plus Y square. Remember that breaking current will correspond to the RMS value, whereas making current we want the peak value, right? Peak value is important to us. Now what is the relationship between making current and breaking current? Breaking current you can get from the making current like this. So we want the peak value, so we can multiply by root 2 into breaking current, and also since the initial peaks, they are going to be much higher in value. Usually the factor by which it is higher, we take it as 1.8, but if it is given separately in the question, you can take that, and often also they might mention it as doubling effect. Okay, so that means the initial current is almost, the peak of the initial current is going to be twice of the normal fault current. Okay, in that case what will you take? This factor you will take as 2. Okay, otherwise if nothing is mentioned, just take this value. And next finally we have the capacity, right? The breaking and the making capacity. So what is this? It is nothing but the MVA rating. So breaking capacity will be simply the breaking current into the transient voltage. Often you can differentiate into symmetric breaking capacity as well as asymmetric breaking capacity. So if it is symmetric breaking capacity, you have to take symmetric breaking current here. If it is asymmetric capacity, you will take the asymmetric breaking current here. Okay. Then what about making capacity? This is going to be the making current into the transient voltage. Okay. So these are the few ratings that are important.